Going to make our measured perspective drawing, and we start with the horizon. The next thing we need to do is we need to establish the ground line. So, as I've already said, this represents a scale interpretation of our physical height from the horizon to the ground. We also need to consider the idea of where we place our picture plane. Now, we can place our picture plane in lots and lots and lots of different places, but for the moment what I'm going to do is I'm going to draw the cube that we've just seen in the previous video. I'm now going to identify my position in relationship to that cube. Now, in terms of measured perspective, we need to make sure that our object falls within a 30-degree cone of vision. If our positioning is too close to this object, we create a distorted perspective. So I'm just going to mark now my position. This is the station point. So I'm going to just label these. So we have station point. We have horizon. And we have ground line. Now for the moment I'm going to just change the density of those lines, just so that they're not so strong in my drawing. So as I've already said, the size of the drawing that I make depends upon the placement of my picture plane. And I can place my picture plane wherever I want to. But what I'm going to do for the moment to make my life easier is I'm going to place my picture plane in contact with the box that I'm trying to draw. Now, I know that from my station point, this cube is this wide. From my station point, it's this wide. So I know the width, the visual width of the cube. On my ground line, what I've got to think about now is that this line represents my pane of glass seen from above, but this line represents my pane of glass seen in perspective. The next thing I need to know is the height of my cube. Now obviously if the width of this is here, then it will have the same width. This height represents the height of the cube, and this is in the same scale as my height. Now if we take the central visual ray, so I'm just going to again label these things, we know what we're talking about. So this is the picture plane. And this is the central visual ray. I know that this is the center of my line of sight. I know that this side of the cube and this side of the cube is parallel to this line. I know that as I look towards the horizon, this is where my vanishing point will be. This is my eye level. As I zoom in to this particular space, I know that this side of the cube and this side of the cube will recede away to the vanishing point. So this represents the side of the cube disappearing off into the distance. This line here represents this side disappearing off into the distance. Of course, if we could imagine this cube to be a transparent cube, then the base of the cube would also be parallel to these same positions, in which case they would also have vanishing points in the same location. And here we have the base, again, going off to the same vanishing point. Now the next question is the depth. How deep is this cube? Well, we've already identified that this is on the picture plane, so we can take those measurements up. So if we move those points, we could of course draw some more lines, but just for simplification purposes, what we now can identify, and I'm just going to draw a vertical line for the moment, and I'm going to change that line to a dashed line for the moment. We know that this distance appears to be this wide on our picture plane. So if we take this measurement and move this to that intersection point, copy and paste that and move that over to here, we now know that visually this cube is this wide where it intersects this line. Do that again without a dashed line this time, and also by holding the shift key down I'll make sure that it's straight across. Now we can also see therefore that this intersects this above line here, telling us that the back view of that cube is here. Now if I start to get rid of some of the unwanted lines, just to clarify our drawing, I'm now going to place in these lines. We've now drawn our cube in perspective.